In the realm of DevOps, testing is a critical component that ensures the quality and reliability of software. Implementing tests in a pipeline involves configuring test tasks, setting up test agents, and integrating test results. This process helps in identifying bugs early, ensuring code quality, and maintaining a seamless flow from development to production. This presentation will delve into the various aspects of implementing tests in a pipeline, providing a comprehensive guide to configuring test tasks, setting up test agents, and integrating test results effectively. Testing in DevOps is essential for maintaining high-quality software. It allows teams to detect and fix issues early in the development cycle, reducing the cost and effort required to address bugs later. Automated tests in the pipeline ensure that every code change is validated, promoting continuous integration and continuous delivery, CI/CD. This leads to faster release cycles, improved software quality, and increased customer satisfaction. By integrating testing into the pipeline, teams can achieve a more reliable and efficient development process. Configuring test tasks is the first step in implementing tests in a pipeline. Test tasks are automated scripts or commands that run tests on the code base. These tasks can be configured using various tools such as Azure DevOps, Jenkins, or GitLab CI. The configuration involves specifying the type of tests to run, unit, integration, functional, the test framework to use, Junit, Nunit, Mocha, and the conditions under which the tests should be executed. Properly configured test tasks ensure that tests are run consistently and accurately, providing reliable feedback on the code quality. Different types of tests serve different purposes in a pipeline. Unit tests validate individual components of the code, ensuring they work as expected. Integration tests check the interaction between different components, verifying that they function together correctly. Functional tests evaluate the software's functionality from an end-user perspective. Performance tests assess the system's responsiveness and stability under load. Security tests identify vulnerabilities and ensure the application is secure. By incorporating various types of tests, teams can ensure comprehensive coverage and robust software quality. Test agents are machines or environments where tests are executed. Setting up test agents involves configuring these environments to match the production setup as closely as possible. This includes installing necessary software, libraries, and dependencies required for the tests. In Azure DevOps, test agents can be configured using self-hosted or Microsoft-hosted agents. Self-hosted agents provide more control and customization, while Microsoft-hosted agents offer ease of use and maintenance. Properly configured test agents ensure that tests run in a consistent and reliable environment, providing accurate results. Self-hosted agents are machines managed by the development team. Configuring self-hosted agents involves setting up the machine with the required operating system, software, and dependencies. This provides greater control over the testing environment, allowing teams to customize it to match their specific needs. Self-hosted agents are ideal for scenarios where specialized software or configurations are required. However, they also require maintenance and management, including updates and security patches. Properly configured self-hosted agents ensure a reliable and consistent testing environment. Microsoft-hosted agents are managed by Azure DevOps and provide a convenient and maintenance-free option for running tests. These agents come pre-configured with commonly used software and tools, making it easy to set up and start testing quickly. Microsoft-hosted agents are ideal for most standard testing scenarios and offer scalability, as new agents can be provisioned on demand. However, they may not be suitable for specialized testing environments that require custom configurations. Using Microsoft-hosted agents simplifies the setup process and reduces the overhead of managing test infrastructure. Integrating test results into the pipeline is crucial for monitoring and improving code quality. Test results provide insights into the success or failure of tests, helping teams identify and address issues promptly. In Azure DevOps, test results can be integrated using the test plans and test runs features. These tools allow teams to view detailed reports, track test coverage, and analyze trends over time. Integrating test results with other tools like Slack or Teams can also provide real-time notifications, ensuring that the team is always aware of the current state of the code base. Analyzing test results involves reviewing the outcomes of the tests to identify patterns, trends, and areas for improvement. This can be done using dashboards and reports available in tools like Azure DevOps, Jenkins, or GitLab CI. Key metrics to analyze include test pass-fail rates, test coverage, and the time taken to execute tests. By regularly analyzing test results, teams can identify flaky tests, optimize test performance, and improve overall test coverage. This continuous feedback loop helps in maintaining high code quality and ensuring that the software meets the desired standards. Test failures are an inevitable part of the development process. Handling test failures effectively involves identifying the root cause, fixing the issue, and rerunning the tests to ensure the problem is resolved. Tools like Azure DevOps provide detailed logs and error messages that help in diagnosing test failures. Implementing a robust process for handling test failures ensures that issues are addressed promptly, minimizing the impact on the development cycle. This includes setting up alerts and notifications to inform the team of test failures and maintaining a backlog of known issues for tracking and resolution. Implementing tests in a pipeline requires following best practices to ensure effectiveness and reliability. Some key best practices include writing clear and concise test cases, maintaining a high level of test coverage, running tests in parallel to reduce execution time, and regularly reviewing and updating test cases. Additionally, it's important to integrate tests early in the development process, shift-left testing, and to use version control for test scripts. By adhering to these best practices, teams can ensure that their testing process is efficient, reliable, and contributes to the overall quality of the software. Continuous improvement is a core principle of DevOps, and it applies to testing as well. This involves regularly reviewing and refining the testing process to identify areas for improvement. Teams should gather feedback from test results, conduct retrospectives, and stay updated with the latest testing tools and techniques. Implementing continuous improvement practices ensures that the testing process evolves with the changing needs of the project, leading to better software quality and more efficient development cycles. By fostering a culture of continuous improvement, teams can achieve long-term success in their DevOps journey. Implementing tests in a pipeline is a critical aspect of ensuring software quality in a DevOps environment. By configuring test tasks, setting up test agents, and integrating test results, teams can achieve a robust and reliable testing process. Following best practices and continuously improving the testing process further enhances the effectiveness of the pipeline. As a next step, teams should start by assessing their current testing practices, identifying areas for improvement, and gradually implementing the strategies discussed in this presentation. With a well-implemented testing process, teams can achieve higher code quality, faster release cycles, and greater customer satisfaction.